In the last video, we made our first asynchronous JavaScript GET request where we were able to fetch the category information whenever the edit button is clicked. In this lesson, let's improve on that and make POST requests because we want to be able to save the categories. Now, making POST requests will be a little bit trickier than GET requests because remember, POST requests are protected by the CSRF protection. So by default, making POST requests using the Fetch API is simply not going to work. But let's give it a try. Let's set up our Fetch API here to make POST requests. We can do that by again doing the fetch, and we can actually copy this and paste it here. And as the second argument here, we'll pass in some options. The first option we'll pass in is the method, which will be post. Then we need to pass in the body of the request, and we want to pass a JSON encoded body because we want to be able to access that as an array within the controller. So let's do json.stringify, and we'll pass in the name because that's the only field that we have within the edit category model. Now we can get the name value by doing edit category model element query selector find input with name and get its value. Let's also pass the content type header to be JSON. Then let's simply log the response that we get. Now let's open the web routes file here and create a new route. Now we're going to make a post route here on the same endpoint. We can set the method name to be something like update or save or something like that. Then let's go to the controller. Let's duplicate the get method and we'll change this to update. We do want to check if the category does exist, so this will be the same. We can get rid of this and we can just set the data to some kind of status equals okay for now. All right, so let's go back to the browser. Let's open the DevTools, switch to the network tab. Let's refresh the page. Click edit, save, and as you can see, a request has been made, but we're getting status 400, which means that our request fails. 400 indicates a bad request, and this is the default failure handler of our CSRF protection. If we go back to the container bindings here and inspect the guard class again, let's search the process method again. If we scroll down here, we have this handle failure method call that is called in multiple places within this process method. And if we inspect that method, we see that if the failure handler is not given, we have this default handler. And this is where we're sending a response with the default status 400. And it has the content type text plain with the body of failed CSRF check. Now we don't see this in the response in here. If we inspect this and go to response, we don't have that. But if we go back to the categories.js file here, we can simply parse the response, and instead of parsing it to JSON, we can parse it to text and then simply log the response. Now let's go back to the browser, refresh the page, hit save. If we inspect the response now, we see that failed CSRF check text is there. And if we switch to the console, we see that that text is there as well. Now, before we implement the solution to fix this, I want to kind of set a custom CSRF failure handler. I don't want to actually respond with the text of failed CSRF check at all. Instead, maybe we can just respond with an empty body and maybe a different status code. 400 is okay, but for me, I think 401 or 403 makes more sense. 401 means unauthorized when authentication has failed, while 403 means authentication was successful, but user does not have the proper access. So let's configure our custom error handler. We can do that from within the container bindings. As you might remember, the guard class accepts an argument called failure handler, which is a closure. Now, instead of defining the closure in here within the container bindings, I kind of want to create a separate CSRF class and call failure handler on that, because I want to keep as much logic out of the container bindings file as I can. Essentially, the container bindings is a configuration file, it's a config file, and the failure handler logic does not really belong here. So maybe instead of defining the closure directly here, we're going to inject some sort of CSRF class here, and then we'll call CSRF failure handler. and this failure handler has to return a closure. So let's create this CSRF class, and we'll create it within the app namespace. Let's also create the failure handler method, and this needs to return closure. So we'll simply return function which will accept 2 arguments. Now if we look at the guard class in here, we see that whenever the custom handler is called, the 2 arguments are being passed. One is the request and the other one is the request handler. So we can accept these 2 arguments. We can basically take this and paste it in here. Let's also copy this handling here and paste it in here, and we'll adjust it to our needs. First, we don't need to write anything to the body. Second, we'll set status code to 403, and we can get rid of that. Let's put this in 1 line. We don't need the body in here at all, so let's get rid of that. And in fact, we can actually make this simpler and just do this directly here. And because this has turned into a single line, we could turn this into an arrow function. Now we could customize it later on if we wanted to kind of add on more information to the response, but for now I think this is pretty good. We do need to inject the response factory in the constructor, so let's do that. We'll add the constructor, response factory interface, and we'll set this to be private read-only property. All right, so let's test this out to see if it actually works. Let's go back to the browser, refresh the page, hit save, and sure enough, now instead of 400, we're getting 403, and logged response is no longer there. In fact, we can even get rid of this part because we no longer need to parse the body. So to fix the CSRF problem, we need to have the token name and the token value and pass those along with our request body. Now, since we're making an asynchronous JavaScript request, we need to add the token name and value within the body right here. The thing is, we need to be able to retrieve the token name and the value somehow so that we can pass it in here. One way is by simply opening our edit category model here and add the CSRF fields in here and then retrieve it from JavaScript. So we could do something like CSRF fields raw, and then this is going to render the necessary CSRF fields for us, and then we can access them using JavaScript, same way we accessed the name input value. Now I'm going to create the variables here, so we'll do CSRF name equals to, and we'll copy this and paste it here, and instead of name, it's going to be name CSRF underscore name, and the value will be CSRF value and CSRF underscore value. Let's pass those now as part of the body here. So we'll do CSRF underscore name equals to CSRF name, and CSRF underscore value equals to CSRF value. Let's go back to the browser, refresh the page, try to save it now, and we're still getting 403. But let's inspect the payload, and we see that we are passing the CSRF name and value properly. The issue here is that the default PSR 7 implementations do not support JSON or XML formats. We need to decode them ourselves from the body. Basically, we need to parse the body to extract that information. Slim PHP framework actually provides a middleware that does that for us, so we don't have to do it manually. All we have to do is add the body parsing middleware to our middleware stack. So if we go back to the middleware.php, we can call the add body parsing middleware right here. If we inspect this, we see that it simply adds the body parsing middleware to the middleware stack. We also see that it instantiates the body parsing middleware using these body parsers, and then it also has the default body parsers. This means that we can pass our own custom body parsers if we wanted to and register this middleware ourselves, but the default ones are good enough for now. If we inspect the default body parsers, we see right here that it has the handling for JSON type, and it calls JSON decode right here. So let's try it out now to see if it works. Let's close this out. Let's open the browser. Let's refresh the page. Let's click save, and we're still getting 403. I wonder why. Let's check the request headers here for a second, and the content type is text plain, but we are setting the content type to be JSON in here. Oh, because it's the headers, not header. I have a typo here. This should be headers. So let's try it now. Let's refresh the page. Click save, and there we go. Now it works. We're getting 200 status code as the response. Now, as you can imagine, in an application, you might have many models like the one that we have for the edit category, or many different forms. Adding the CSRF fields to all of those forms and then retrieving them via JavaScript this way is sort of unnecessary. Also, there is one issue here. We're kind of hard coding the CSRF name and CSRF value names of these input fields, and these can be changed, right? These are customizable. If we go back to the guard class, we see that the name that it uses to extract the data from the parsed body is the token name key and the value key. And if we inspect these, we see that it's set to prefix underscore name and prefix underscore value, and the prefix by default is set to CSRF. So we are essentially just hard coding the CSRF name and CSRF value, and that's not a good practice because this can change. There is actually a better way to handle this. Since we are using persistent tokens, we could store the CSRF key names and values in some meta tags on the page load and then access them within JavaScript. We could open the layout template, and within the head tag, we can add some meta tags right here. So we could do meta name and access the CSRF keys and the name, because remember, if we inspect our middleware again, we have the CSRF fields middleware, and in here we're passing the fields, but we're also passing the keys and name value. So we can access these individually to sort of build this kind of thing right here, instead of actually adding the input fields to each form that we're going to be using for our asynchronous JavaScript calls. So let's go back here and we'll do content equals CSRF name, and that's good enough. Let's duplicate this, and this is going to be value, and this is going to be value as well. So we have the CSRF name key, CSRF value key, the actual CSRF name value, and the actual CSRF token value. Now within the categories.js file, instead of doing this, we could maybe create some kind of function that extracts the CSRF values. Maybe we can have something like function get CSRF fields or something like that. And here we'll create the CSRF name key equals document query selector, and maybe we can add some ID tag to our meta tags here. So we'll do ID CSRF name and ID CSRF value. And now we can do the query selector by CSRF name and get the attribute of name. We'll duplicate this and we'll get the CSRF name value, which will get it not from the attribute but from the content. And in fact, we can probably extract this into CSRF field like this, and then get the attribute this way and get the content this way. And then we'll duplicate this and we'll have CSRF name field and CSRF maybe value field. We'll change this here, and then this will be CSRF value. And we need to duplicate these two lines and change it here to value and get the attribute the same way. Now we can simply return an object that will contain the proper key value pairs. We can set the keys this way. So we can do CSRF name key, and this will equal to CSRF name, and then CSRF value key will equal to CSRF value. And we need to fix this here. This needs to be CSRF value. All right, let's format the code, and we can actually call this function in here to get the CSRF values. So we can get rid of this and simply do get CSRF fields. And we can also get rid of this, and this should work. Let's go back to the browser. Let's refresh the page. Let's try to save. And sure enough, we get the response 200. The payload contains the correct CSRF name and CSRF value, and their keys are correct as well without us having to hard code those keys. Now we can also get rid of these CSRF fields from the edit category model because we no longer need that. And let's make sure that this still works. So let's refresh, click save, and that still works. We're getting 200 status code. Great, so the next step is to actually save the category name in the database, which means that we'll actually need to add some validation. So if we go back to the categories controller here, we can do the similar validation we did when creating a new category. So maybe we can copy this here and paste it in here, and we'll create a new validator class. So instead of create, this will be update category request validator. And I know that it will probably have the same validation rules, but I like to keep them separate even if there is a little bit of duplication. So let's duplicate the create category request validator here and change this to update category request validator. Let's change this as well, and we'll have the same rules here. Let's go back to the controller. Let's import this class. Let's open the browser, refresh the page. Let's try to save it. Let's check the response. This is empty, but it should technically be status okay. That's probably because we're not parsing the response. So let's add this line right here, and that should work. Let's try to refresh this, save again. Inspect response, and yeah, we're getting status okay now. But if we save an empty category, we see that we're getting a 302 response code, and then it's trying to redirect us back to the categories page. And that's expected because our controller is throwing a validation exception, because this validate method on the update category request validator is throwing the validation exception. And then within the middlewares, we have the validation exception middleware handler, which basically wraps the request handling into try catch block, and it catches the validation exceptions, and then we generate a custom response. And here we are setting the sessions, and then we are redirecting the user back to the refer with the status of 302. Now this is okay for when we make regular requests, but it does not work for asynchronous JavaScript requests or AJAX requests, because we don't need to redirect and we don't really need sessions. We can simply return a JSON response containing the validation errors, and then we can have the front end, the JavaScript, decide if they need to do redirect or show the errors or whatever. So what we need to do is that we need to modify this and detect if it's an XHR request. And if it is, then instead of redirecting, we need to prepare a proper JSON response. We're not going to do that in this lesson though, we'll do that in the next one. Thank you for watching, smash the like button if you liked it, and subscribe to the channel if you haven't already done so to stay up to date and get notified whenever the new videos are published. Thanks again, and I'll see you in the next one.